Today, the vast majority of government IT systems are built as massive blocks of functionality. Under that model, each system function is virtually cast in stone. This makes for a heavyweight system design, also known as monolithic architecture. Whilst initially easier to build, monolithic systems suffer from one major problem: upgrades. In fact, every time new functionality or a bug fix is applied to the system, heavy machinery is practically required to retire the old version and bring in a new one. This leads to long, complex, and costly upgrade cycles, which can be risky business. Extensive efforts go into testing monolithic system changes, yet major releases often introduce unexpected complications that can be painful to clients and lead to user frustration. As great efforts are made to fix bugs and deliver on immediate promises to improve the user experience, new complications risk being introduced with every change. Left unchecked or insufficiently tested, these complications can lead to all hell breaking loose. Another shortcoming of monolithic systems is the amount of duplication. Take correspondence, for example. Most monoliths have a correspondence functionality of some kind. And today, if we decided to standardize and introduce a new communication channel, we'd have to redeploy the correspondence functions across every monolith in the digital landscape. That's not a cheap endeavor when you consider the time and expertise required for each change to each monolithic system. It's time to think outside the box, or in our case, outside of the monolith. Rather than burying functionality in one or more very large systems, we can design each system function as a reusable lightweight service. Take ESDC's pension systems modernization projects, for example. As part of the migration of old-age security applications from the mainframe to ESDC's modern platforms, the project teams are architecting OAS functions such as client address, contacts, benefits, and more as distinct services. These services are interconnected with a high-speed messaging backbone, and they make themselves visible to client systems through what is referred to as an API. This combination of services and APIs is what we refer to as microservice architecture. A key benefit of this lightweight service model is that adding or modifying functionality is easy. For example, a new correspondence channel could be brought in with speed and agility without having to redeploy the whole system. This reduces risk and, of course, the cost associated with upgrades. Another advantage of using the APIs and microservices model is the portability to the cloud. A microservice and its associated API, such as correspondence, could transparently be migrated using cloud-native capabilities, thus accelerating migration to the cloud and to the shared services and state data centers. Microservices and APIs are fully aligned with the GC enterprise initiatives such as the Canadian Digital Exchange Platform. Departmental services can be registered in the GC API store, allowing internal and external developer communities to innovate and build user-friendly applications for any device. With microservices and APIs, ESDC can also share key information or events such as death notifications with other departments through the GC messaging capability. And ultimately, microservices and APIs can interact with other government services across the digital landscape.